Well, hello. This is a quick video, well, won't be so quick, but to show how OpenSCAD, an open source computer assisted design and drafting software, can be used to develop a 3D object ready for 3D printing. The great part about OpenSCAD is it uses basic coding knowledge that one might have in a way that can handle the mathematical constraints and requirements to create something that is 3D printable. The term is called manifold, meaning that the object must create a singular shell for 3D printing, must not have any overlaps and whatnot, because the printing software is a completely different application than what was used for design. So printing software must be able to analyze a design and determine where the object should be and where the object should not be. And that can be ambiguous if you don't have a manifold design. So I won't go into more details than that, but just to say that OpenSCAD is great for that. Also, it's good for anything that is best replicated and whatnot, and or iteratively improved, because the fact that it's built upon creating sort of a script that creates your image or your object, that can be adjusted over time if you're trying to design something and you're not sure the best way to look and or how well it will print, and you need to potentially improve that. So here's the one for the 2023 IS 3D printing giveaway, or the thing that we create every year. This is the first time that a wreath was done. So I create a few centralized parameters, such things as the number of leaves. I use holly leaves to make the wreath. The radius, it's important to think about units, and 3D printing typically defaults to millimeters. So this creates a circle that is 23 millimeters upon the radius. And that's going to be the size of the wreath. The loop height is here. I was trying to adjust what is the thickness of the loop that you would use for the ornament hanger. Here's the text string. I put a bunch of spaces in, so this text string will be stretched around the circle. And so the initial and ending spaces account for the bow. So you don't want the letters to be where the bow is, otherwise they wouldn't be easy to read. So I could have done it a different way, but this was a fast way of doing it. Then I have I set the text radius to be the same as the wreath radius, just so we can kind of get a sense for where the size should be. The font size is there, and I chose Arial Bold. In general, for 3D printing, you want to pick fonts that don't have serifs, have very regular, clean lettering. Usually you want to stick with all caps if possible. And bold makes the thickest letter in order to deal with printing. Thin letters can be spindly and might not actually even resolve and won't be able to be printed in such a way that you can read the entire letter. So then I create an angle, something called a step angle, which is the 360 degrees around the circle divided by the number of leaves. So you know what angle to rotate in between each leaf as you go around. And hopefully you can kind of see there's like one leaf, and then there's another leaf, then another leaf, then another leaf. And if you look, they're kind of alternating in heights, which will be important later. I then have a bunch of modules, and so in overview, here's a module that creates the leaves and the wreaths here. That's one entire module. It steps through all the numbers of leaves that you'll have. I'll come back to that later. Here's a wreath for putting the text on the circle, and so that does the text part. Here's one for doing that little loop at the top of the ornament. Here's one that creates the bow and places that. Here's one for the spider in the center. And then I have modules for the red and green parts. So to give you a little bit of context, most 3D printers that can print in more than one color require a separate design file for each color. and so it keeps them distinct and goes through the analysis software thusly. So that's one of the best parts about using something like OpenSCAD is I can code the two colors together, but I can have them separate as needed, and I'll show you a little bit later about how that comes into play. But in general, all of the red parts that are going to be printed, I call those modules to create them, and then I give them all the color red, and I unite them. So this is a Boolean operator for union or join or add that combines geometrically all of these shapes into a single part, which will be important. Now I do that for the red parts, and I do that separately for all the green parts. Then I have a slightly different module here for actually printing the parts. Now this is important. When creating the two separate files for the 3D printer, they can't overlap at all in space between any of the mass, because we kind of know from physics that you can't have two objects occupy the same place in the universe. So this only has to be done once. It doesn't have to be done for both colors. So here's where I actually do it. So to actually make the version of the printed green part that will actually export and import into the 3D printing software, I subtract the red parts from the green parts using this difference command. And so that ensures that I end up with an object that will be mostly the green parts and will definitely have holes wherever the red parts will be, such that I won't run into any interference or overlap when we get to 3D printing. Then lastly, I have this mechanism here that I can use to pick what is being rendered. So here's where I actually call the fact that right now I'm calling the red routine and the green routine. So that's why we see both the red and green parts. Now when we get ready to actually print, we'll be changing the commenting and whatnot for that. So let's look at each of the modules a little bit deeper if you are at all interested. So in the holly leaf, that's probably the most complex one. So all of these objects, so the spider, the holly leaves, and the bow, all import files that were designed elsewhere. So let me show those very briefly using the preview tool. So I have loaded up here each of the designs. So the spider I took from a University of Richmond spider logo file and used Adobe Illustrator to trace the outline of the shape until it was a vector drawn object, and then I used OpenSCAD to import that drawing and then extrude it. So this is a solid object, and I guess if you zoom in really close you'll see that it's really just a like a prism. You take the thinnest, infinitesimally thin surface of a spider and then you give it some Z axis on it. So we kind of do the same thing for the other objects. Here's the holly leaf, which I also took from a line art drawing, and I made it such that veins are represented by hollows, where they're, to try to give you a sense of where the vein would be. And so again, it's extruded through the Z direction, so you actually have a solid object of it. The bow was taken actually from a Thingiverse design of just a bow, so that probably took the least amount of work, and so that's represented right there. So when I get to making the wreath, we'll work from the deepest part of it and then back outward, and hopefully that'll be a way to explain this. So we look within the routine for placing the leaves, and so at the lowest level, this is the line where it actually imports the holly leaf, and so file name is being passed to the routine, and so file name was like holly leaf STL file. We take that holly leaf and we scale it. So it will scale the holly leaf this amount in the x-axis, this amount in the y, this amount in the z. So if it was 1, it leaves that dimension untouched. So we're scaling it slightly up in the x and y axes and a little bit lesser so in the z axis. These I just arrived at from trial and error. on the holly leaf. So, went to see what looks good. Now from that we also need, so that's assuming that we've already placed the leaf using some of the code above that. But with that leaf we can rotate it, and this was useful because I can have the leaf just go along the wreath, but I found that rotating it by the angle of where it should be on the wreath and a slight angle of 5 degrees, which I arrived at also through trial and error, I got a somewhat pleasing arrangement of the wreath. So I could have changed that. So for example, I could have made that 10 degrees, and if I hit preview, take a look at what happens in the drawing. So it just kind of changes the angle of each leaf. And so I could have made it, let's say, 40 degrees. And then there wouldn't be much overlap between the leaves, and so we wouldn't have as sturdy of a wreath. But one could do that if you wanted. It would also look a little bit like a hexagon, I guess. So, it is whatever you created. So it's nice to be able to do these kinds of things because you can kind of do like a what if as you're designing it. Now we need to actually place where the leaf is on the wreath. So let's so go back to the original wreath. So we need to translate or move this leaf, this one leaf, where it should go on the overall wreath. And so we translate it by this X, this Y, and this Z. So the X is determined from geometry that we take the radius of the wreath and the cosine of the angle for that one leaf, and that arrives at the X value of where it should be. And we do the same thing with a Y position, which will be determined from the sine of that angle. And so that's what's needed to be able to place and rotate each leaf. And also I have a little bit of commented out code for creating a cylinder. So I like to have a little cylinder just to make sure the center of each leaf was correct. But I don't need that in the normal usage of the code. Now, outside of that, I have a routine, and this is where it gets a little strange. For the even leaves, I was trying to initially use a different leaf with a different curvature just to kind of show more uniqueness. And so I was importing a different leaf. But in the end, I have two sets. So the even leaves around the leaf use this code, and the odd leaves use this code. In general, there isn't much of a difference. You'll see most of the code is the same. The main difference is in the scaling of each leaf, and that's really just in the Z-axis. This one, it scales it up 1.1. This one scales it down to 70%. And the reason why is because I wanted these leaves alternating in thickness to kind of give some sense of variation and, I guess, organicness to the wreath. So that was given to me by the fact that I separated the even and the odd leaves. Both of those routines are sitting inside the overall routine that cycles through the 12 leaves that we have in the design. Lastly, I rotated the entire wreath by an angle. It was kind of an arbitrary 45 degrees. If you look, I could have had it 0, and again, if we look, it just makes a loop. I actually liked having that little bit of leaf actually in the loop, and that made it a little bit stronger, because if you can imagine, the loop kind of uses some of the plastic from that leaf to help strengthen it. So that's why I chose that. So this was the entire module for creating the wreath itself. Now we're down to the text. So we break up the text into each letter because we're going to have to place each letter somewhere on the wreath, and we want to rotate the angles such that they're all readable. So this line here is actually placing each individual letter of text using the right font, the right size, using some V alignment and H alignment as such. And then it rotates each letter based upon its angle, its step angle around the circle. And so this ensures that each letter has the bottom of it pointed towards the center of the circle or the center of the wreath, so they kind of look uniform, if you will. I then translate them using really just bring them up 1 millimeter in the z-axis, just so they're not going to show through the bottom of the wreath, because we want the bottom of the wreath to be uniform and use a single color, which I'll get to in a minute. Now, where does each letter go? That's pretty important, just like we had the leaves and the wreaths. So using the same geometry rules, we're taking the radius, and for the x position, we're multiplying by the cosine of the angle, and actually it turns out it's 3 pi over 2, or 270 degrees minus the angle, works. And then same thing for the y, it's the sine, but it's the sine of that angle which places it. The angle itself is derived from where it sits in the for loop times 360 divided by the number of letters that kind of go around the entire, or characters that go around the entire circle. And then I used another fudge factor, so in addition to the spaces at the beginning and the end, the 10 helps spaces it just perfectly. So this is a little bit of a trial and error fudge factor as well. So there's the text routine. Next we have the placement of the loop. And so to kind of show you a little bit more about how the coding works and the utility of it, I'm going to zoom in on the loop itself. So the loop is created by an outer cylinder, and cylinders in OpenSCAD are solid, but we want a loop. So we're taking a big cylinder and we're subtracting out a little cylinder in space. So to do that, we create one, and so here's the outer cylinder. And so we have used that one parameter for the height or the thickness of it, and the radius is 5 millimeters. Then from that we're going to subtract out this smaller cylinder. So the radius is only 3 millimeters. So in effect, this loop is 2 millimeters thick, 5 minus 3. Now we don't use the same height because as a strange artifact in the way these files look, it turns out that if you take a cylinder of particular height and subtract out another one of the exact same height, you might get an artifact at the very top and or the very bottom of the cylinders. So what I actually do is I take the smaller cylinder and I make it slightly larger. So the height is actually 1 millimeter thicker than the other cylinder, and then I move it a half of a millimeter vertically downwards. So in effect, the one that's being subtracted is half a millimeter below the big cylinder and a half millimeter above it. So that makes a clean difference for that cylinder. So that's kind of how OpenSCAD works for kind of doing this Boolean operation part as well. So hopefully that helped. The bow one is a fairly simple routine. I import the bow STL file. I scale it. In this case, I really am just scaling it vertically, the thickness of that bow. And then I translate it a little bit. So the -20 is to move that bow 20 millimeters from the center or the origin. And I move it up just a little bit, so again it's not at the very bottom and showing through the green part. Then lastly, actually there's just the calling of that routine. Now the spider is very similar to the bow. I import the spider file, I scale it to whatever works for me. Again, these can be found by trial and error. I translate it a little bit. It turns out that 1 millimeter helps. Something to note is, and this is in general has on all 3D printed objects, has been important for the spider, is that because of the thin and spindly legs, it's nice to have the ends of the legs, so the kind of like the end and also the end that goes into the torso cemented, instead of having just kind of free off into space. It's nice to be able to have the ends go around the wreath. By doing that, it makes it such that these thin spindly legs, you don't have to worry about how the end of it sticks to the print bed of the printer and potentially running astray. So this is a lot easier to print than if the spider was moved off. So part of the scaling and translating of the spider was done to deal with that problem. Then, just like I said before, so I have the red sections here. So all the red components are printed in this routine, or put together in this routine. And again, they're united in order to create a single geometry. And then all the green parts here. Now, the only other thing I didn't really get to, you may have noticed, may not have, is that the bottom of the ornament is all green, even though the spider is red. And same thing with the bow. The bottom of the bow is green, as you see on the ends of the ribbons, while the top is red. And the reason why is because I had this original design with the spider actually touching the print bed and the bow touching the print bed and even the letters touching the print bed. But it turns out that one, that adds time, and two, that creates some risk for having the print not stick very well to the print bed. So it's much easier, quicker, and more reliable to have a single color at the bottom of a 3D print job, even if you're using two colors. So in order to do that, I replicated all of the parts of like the letters, the bow, and everything in green, just for the bottom millimeter. And so when I am doing rendering the green parts, you'll see that I have like the bottom of the bow, and of course I was going to have the leaves anyway, and also have the spider. Now the only other thing is I made a second version of the spider a little bit thicker for the green part, and so that created a nice little outline in 3 dimensions of the spider to really set it off than if I had made the green part of the spider the same thickness as the red. So technically the green part of the spider uses a different STL. It's really the same spider, just a little bit of a wider spider. As you can see at the bottom, it looks like a hairier or beefier spider. So, like I said before, I render the green parts here. They're all united into a single geometrical object. I did the same thing for the red parts up here. I do the differencing here to make sure that they are unique in space. And then I have the ability to render them. So just declaring a module, any of these modules up here, doesn't mean they actually get rendered. So this part down here is kind of like a picker to pick what gets rendered. So I have the red and the green parts being rendered right now so you can see them. And if I just use this is the preview button, this is what you see. Now to actually create these in such a way that I can 3D print them, I will remark or comment out those, and I uncomment in turn each of these. So if I can quickly preview this, but to actually render it at full quality, I use the full render button. And so by doing that, I now have a high quality version of what I'm calling the red parts ready to 3D print. And I can export this to an STL file. You won't be able to see it completely, but if I go to the menu, File, and then I do Export, I can export to an STL file. Now when I'm done with the red parts, I then comment that out again, I uncomment the green parts, and I render that part. Now there's a weird kind of green artifact, but as you can see, it does do the green parts, and you'll notice how there are holes wherever there are red parts. So it's done the math and the geometry all well and good. And now likewise, I would export this to an STL file. So once I have that, I have the 2 STL files, and I can go to the printing software. So to give you a sense of the printing software, this is what it looks like. Now, so this is a production job. Once normally I would print one wreath initially, ornament, and make sure it works well. and then I try to optimize it to print as many in a single job as I can to minimize the amount of the frequency to which I have to do something manually at the printer. So just to show you what that process looks like, I would import the two files. Remember, the red and green are separate. So I go the printed green parts and the printed red parts. And there they are. Now on the printer, using this, so I have an Ultimaker, or the Information Services has an Ultimaker 3 printer, which can do two colors. It uses Ultimaker Cura free software to print. So the wreath itself right here, if I select it, this needs to use the green filament. And so in the printer right now, Extruder 2 is the green filament. So if I select it, I right click on it and say declare that it should be using Extruder 2. And this one by default is using Extruder 1. Once I do that, I can select the two objects and unite them, merge them. And so as long as the two parts were designed using the same software like I did in OpenSCAD and use the same origin, then Cura knows where in space to merge the two files, has a common reference, and so it actually locates the two, and there will, due to the effort that we made in OpenSCAD and now in Cura, there is no overlap in any places in Cartesian space in which the two designs, red and green parts, will overlap. So that's kind of what it looks like. Now I chose to print this and I did some testing, and again I went back and forth between OpenSCAD and the printing software to optimize everything. Then I decided I could get away with scaling this a little bit larger to make it a slightly nicer ornament, so I can go to the scale section. And so I scaled the X and the Y by 130%. I decided like 110 was good for the Z axis, and so did it that way. Now you'll notice that now well, you don't necessarily know in Cura, but it's showing that the coloring scheme changes, and this is a warning that it's unprintable, and that's because I scaled it up and the object is now overlapping with something called a priming tower. So if I move the object out of it, it'll look correct again. Now at this point I would make sure that it starts off at Z of 0. That can sometimes be a bad artifact because you want the object to start at the bottom of the print bed to print correctly. So I changed the Z to be 0. Now I can adjust other things such as the temperature of the printing conditions, the settings for the one extruder, the other extruder, the height, the thickness, the resolution, the speed, all this kind of stuff. But once I'm done with that, I can minimize that and I slice. And slicing is the process of analyzing the object, analyzing it for printing, and deciding what needs to be printed at every layer of the object. I can then preview it and it'll show you the simulation of what the object will look when printed. And unfortunately, now the colors of the two extruders look the same, and it's hard to see. I can have it wrap the object in a skirt, and that skirt is just to help make sure that the plastic is flowing by the extruder well before it starts printing the job. But also, it gives me a chance to, when I'm actually watching the printer print, that I know that if the printer head can make this entire distance without having some kind of obstruction or whatever, I know that it's going to be able to succeed, at least as far as those factors go. Lastly, it creates a priming tower. Now, because the printer is switching between heads, there's a possibility that there could be some stray filament from one head that interferes and causes some ugly artifacts on the other color when the second one's printing. So it creates this priming tower. And so if you look at this, I can have it only show, like currently it's only showing extruder 2. So, as it's only extruder 2, it's only showing the wreath part, the green part, and the green part of the priming tower. And so you see it creates a base to be sturdy and then creates a wall for where the green is. And if I look at only the red parts of the print, it still creates a wall and then a flatness around the outside, and of course the print. So in effect, if you look at the two colors together, it's creating a priming tower is made up of both filaments, both being printed all around. So whenever the printer switches between extruders, it does this, like, let's say a trial ring around this thing and make sure that you don't have any extra plastic that will cause some blemishes in your object. When it's all done, I would hit print over network, and that would send the job to the actual printer. Now it's important to note that after you've sliced it, and before you do that, it'll show you that it'll take about an hour to print each wreath, and it'll use 15 grams of material to do that print. So you can use that to kind of gauge your resources. And it'll even give you the breakdown of how much filament of each type. So it's using about 5 grams of one filament, about 10 grams of the other overall. Now, filament costs about $22 per kilogram or 1,000 grams. So you could use that to determine that each ornament will be 20-some cents, 30-some cents to print. So pretty cheap and easy. Now, if we go back to what I actually hit undo a bunch of times, we can go back and see that in production I was doing 4 wreaths to make it such that each one takes a little over 4 hours. So I only have to baby the printer every 4+ hours to do something to it in between print jobs. Now, this software it allows me to actually monitor the print job, so I can look at the webcam on the printer. So this shows me in real time the actual printing of it. And so it's not the best angle if you really want to see the overall design, but this is the best angle to see if there's a problem. If there's any stray filament, if the filament is not adhering to the print bed or earlier layers, or if it's warping, meaning it pulls away from the print bed, you can see it very easily with this angle. But you can see that this red and blue line here that I'm showing now is the outline of the print. This kind of wedge shape here is the first ornament closest to us in the front and to the right. There's the ornament in the back, in the front left. There's the ornament in the back left. And here's the ornament right where it's printing right now in the back right. And we can't really see it, but the priming tower is kind of where the mouse pointer is right now. So that's kind of an overview of everything that's involved. Thank you for your attention. Sorry, I forgot to mention, so where is OpenSCAD information? So you can, if you want more information about OpenSCAD, you can go to OpenSCAD.org and see more about it here, and even see a more complex design object here, and they usually have some good showcase items, and you can even access the software. It's available on Linux, Windows, and Mac, and there's a great cheat sheet here whether you know OpenSCAD or whether you know coding and just want to get a quick getting started to be able to try to use some of your knowledge, transfer your knowledge from coding to what it takes for OpenSCAD. You can use this reference here. It'll show some information about the different kinds of operations, commands, routines, a little bit about how does math actually get performed, how you do the transformations, special variables that are useful, a little bit about sort of Boolean operations, which would be pretty important, and then it goes into math and actually how you do flow control in coding, sort of the scripting that's involved in OpenSCAD there. Then test functions for being able to see whether something renders or not, and whatnot. So hopefully that's of use to you. Thank you and have a great day.